Hello everyone. Today I'm going to talk about how you can calculate the electricity units that can be stored in your electrical batteries, how you connect them in series and parallel, and what impact does these connections have on the capacity of your battery to store electrical units. I will also tell you how you can calculate the amount of units that you can actually retrieve from your electrical batteries. So first talk about when connecting two batteries in parallel. We have here two batteries. Each battery is of 200 ampere hours and the voltage across its terminal is 12 volts. Now in parallel connection, you can see how these connections are made. In parallel connections, when two batteries are connected in parallel, the voltage across the common terminals remains equal to the individual battery voltage. This battery has a potential difference of 12 volts across its terminal, and this battery also has a potential difference of 12 volts across its terminal. And when we talk about collectively and it's connected in parallel, this system is 12 volts. But the current capacity, the amperage, it adds up to become 400 ampere hour. So how can we calculate the kilowatt hours? Now kilowatt hours are calculated by multiplying the battery amperage by battery voltage. Replacing these values, 400 is the battery amperage in which we add these two, and 12 volts is the individual battery voltage that appears across the common terminals. So the kilowatt hours calculated through this equation are 4.8 kilowatt hours. Now let's look at what happens when you connect them in series. We have the same two batteries, 200 ampere hours, 200 ampere hours, and we have connected them in series connection. You can see that in series, the voltage adds up. The voltage adds up. We have 12 volts across this and 12 volts across this. And these two add up to form 24 volts across the common terminals. But the current capacity actually remains equal to the individual current capacity. Like this system will become, when voltages are add up, they are 24 volts and the current capacity is 200 ampere hours. Replacing these values in the equation, we get the same amount of kilowatt hours, the same amount of electricity units, which are 4.8 kilowatt hours. The series connections provide high voltage, but the total current that can be provided by series connection is equal to the capacity of the individual batteries. Now, to calculate the amount of electricity units that we can actually retrieve from the battery, we have to know about the factor of depth of discharge. Manufacturers specify the depth of discharge of the batteries. Different battery types have different limitations of depth of discharge, such as lead acid batteries. They usually have a depth of discharge of around 50%, and lithium-ion batteries, they can have a depth of discharge of around 90%. Depth of discharge actually tells us how much of the energy stored in the battery can we retrieve without actually causing long-term damage to the battery. So let's suppose that we have a depth of discharge of a battery that is given to be 60%. Then we can replace this 60% in this equation, and we can see that kilowatt hours capacity comes out to be 2.88 kilowatt hours. Previously we calculated the ampere hours, the kilowatt hours to be 4.8 kilowatt hours, but the useful amount that we can actually get from the batteries is 2.88 kilowatt, and it depends on the depth of discharge of a battery. The higher the depth of discharge, the more power we can extract from the batteries.